Okay, still on our tutorial set, we had a video solution of question 8, and now we move to question 9. For question 9, we have some functions over there, and we are asked to find the derivative of those functions with respect to x. Okay, so we move to question 9a. Question 9a says that find the derivative of g of x equal to square root of s squared plus square root of s squared plus square root of x plus 1. We have this function and I ask to find the derivative. Okay, so we find or we write this expression here as s squared plus square root of s squared plus square root of x plus 1 all exponent 1 over 2. This bigger square root is the same as the exponent 1 over 2 over there. Okay, so our g prime of x is equal to d dx of s squared plus square root of s squared plus square root of x plus 1 all power 1 over 2. So looking at the nature of this expression, it looks like f of x exponent n. Okay, so let everything here be equal to f of x, and our n here is what 1 over 2. So we are going to use the general power rule or the power rule to solve this question over here. So what we do is that we drop the exponent, which is 1 over 2 times the original function exponent was 1 over 2 minus 1. So we have s squared plus square root of x squared plus square root of x plus 1 exponent minus 1 over 2 times the derivative of what is inside the bracket. So we have s squared plus square root of s squared plus square root of x plus 1 dx. Okay, so we have this one. We drop the exponent, we write the original function inside the bracket, then we subtract 1 from the exponent, we get minus 1 over 2 times the derivative of everything inside the bracket. That's what we have over here. So we have our g prime of x, g prime of x to be equal to 1 over 2 square root of s squared plus square root of s squared plus square root of x plus 1 times the derivative. So we differentiate term by term. We differentiate the first term and the second term. So the derivative of the first term will give us 2x plus the derivative of this one. That one we can't get it straight here. We have to write the derivative and then later we find the answer to that. So you have d dx of s squared, of s squared plus square root of x plus 1 all exponent 1 over 2. Okay, so here to the bigger square root over here is the same as the 1 over 2. Okay, so we now find our derivative of that one. So we have this one is equal to 1 over 2 square root of s squared plus square root of s squared plus 1 square root of x plus 1 times 2x, and the derivative of this one we are going to have plus Okay. Plus 1 over 2 times x squared plus square root of x plus 1 exponent minus 1 over 2 times the derivative of what is inside the bracket. Okay, so the derivative of what is inside the bracket will give us 2x plus the derivative of square root of x plus 1, and the square root of x plus 1 can be written as what? X plus 1 power 2. So we have 1 over 2 times square root of x plus 1 times the derivative of what is inside the square root, and we have 1 over the so we can further simplify this one. We see that if you can further simplify this one, or you leave your answer as such, so you can write 1 over 2 square root of x squared plus square root of x squared plus square root of x plus 1 multiplying 2x plus 1 over 2 square root of x squared plus square root of x plus 1 multiplying what is here, so times 2x plus 1 over 2 square root of x plus 1. So this expression here is a derivative of g of x. So our g of x, or g prime of x, is equal to that. Okay, so let me take it again for maybe you are not getting something. So let me take it again for more clarification. Okay, so we have g of x equal to that, and I also find the derivative. So what we do is that we write this one as x squared plus square root of x squared plus square root of x plus 1, all exponent 1 over 2. This 1 over 2 here is the bigger square root. Okay, so we have g prime of x equal to the derivative of this one, and this one looks like a function f of x exponent n. So we can use the power rule over here to find the derivative. So what we do is that we drop the exponent, which is 1 over 2. We write the original function, which is f of x, like this. Then we subtract 1 from the exponent. That's what we did here. 1 over 2 minus 1 will give us minus 1 over 2 times the derivative of the function inside the bracket. So times the derivative of the function inside the bracket is what we have over here. And this 1 power 1 minus 1 over 2 can be written as this: 1 over 2 square root of x squared plus square root of x squared plus square root of x plus 1. Okay, then the derivative of this one, the first one, will give us 2x times the derivative of this expression over here. That's what we have written over here. So our next step, we maintain that one, we maintain this one, then we come here, finding the derivative of this one, we drop the exponent, which is 1 over 2, we write f of x, or our function, over here like that. We subtract 1 from the exponent from here, we have minus 1 over 2, and when we finish, we differentiate what is inside the bracket over here. Okay, so the derivative of this one will give us 2x for the x squared plus the derivative of square root of x plus 1. Okay, we drop the exponent, which is 1 over 2. We subtract 1 from it, so it will be exponent minus 1 over 2. It will come down, and it will be a square root of x plus 1 times the derivative of what is inside the square root here. The derivative of x plus 1 is 1. That's how come we have the 1 over here. We write our g of x, or our g prime of x, as that. Okay, so take a moment to go through to see if you are okay. Okay, I believe you have not gotten it. So we go to the B part. The B part. So the B part, we have f of s equal to log of s plus square root of s squared minus 1 plus 4 exponent sine x. We are asked to find the derivative. So the derivative of this one, we find the derivative 10 by 10, okay? So we find the derivative of log s plus square root of s squared minus 1. Then we find the derivative of 4 sine x. Then we add them to get our f prime of x, okay? So we write f prime of x is equal to d dx of log x plus square root of s squared minus 1 plus d dx of 4 sine x. So here we have the derivative of log of a function, and we know that we know a rule for finding this. So the rule says that find the derivative of the function inside the log. You can call it g of x or h of x or whatever, over ln of the base of the log. So here you can see that the base of the log here is 10 times the function inside the log. Okay, so we are going to have the derivative of x plus square root of s squared minus 1 as 1 plus the derivative of this one will give us 1 over 2 square root of s squared minus 1 times what is inside over here, the derivative, which is 2x, over the length of the base of the log. And here the base is not written, and whenever the base of the log is not written, we assume it is equal to the base 10. So we write ln 10 multiplying the original function inside the log. So we have x plus square root of s squared minus 1. So this one here gives us the derivative of log of that one, everything over here. Then we have plus the derivative of 4 exponent sine x. And this one too, there is a rule for finding the derivative. So what we have to do here is to find the derivative of the exponent, which is sine x. You write it times the length of the base. So we have ln 4 times the original function. So we have the derivative of sine x will give us cos x times the length of the base, which is ln 4, times the whole function, which is 4 exponent sine x. So we have f prime of x to be equal to, you see that these two will cancel that 2, and we have 1 plus x over square root of s squared minus 1 all over ln of 10 times x plus square root of s squared minus 1 plus cos x ln 4 exponent sine x. And you can further simplify it multiply through by the denominator here plus this 1 over, or you can just leave it that way. Okay, they are all accepted. So let me take you back again. We have f of x equal to log of x plus square root of x squared minus 1 plus 4 exponent sine x. You are asked to find the derivative. So we find the derivative of both sides, and we have f prime of x is equal to d dx of the right hand side. Okay, and the derivative is what? Is distributive. So we can just distribute the derivative, and we have d dx of log of x plus square root of x squared minus 1 plus d dx of 4 exponent sine x. Okay, so we find the derivative of this one, and for you to be able to find the derivative of this one, you have to apply a simple rule. You don't need to go through the whole process. So here we say that we find the derivative of the function inside the log. Maybe you can call this one g of x. So you say that you find g prime of x over the length of the base of the log. Here the base here is 10. So you write the length of 10 times the function inside the log, which you call g of x. So you write it that way. So when we find the derivative of the function inside the log, this one, this x, the derivative will give us 1, and the square root of x squared minus 1, you get 1 over 2 square root of x squared minus 2x. Okay, how do we get it? So this one, we can write it as x squared minus 1 exponent 1 over 2. Okay, so you drop the exponent, which is 1 over 2. You subtract 1 from the exponent, which will give you x squared minus 1 exponent minus 1 over 2. And that one will come down, and you have 2 square root of x squared minus 1 times the derivative of the function inside the square root, which is the 2x. Okay, it's as simple as ABC. Then you write over the length of the base, which is 10, length 10, times the function over here, or the expression over here, which is x plus square root of x squared minus 1. So we are done with the first part, and the second part we have d dx of 4 exponent sine x. Okay, and this one too, there's a rule for finding it. It says that when you have a constant exponent, a function, find the derivative of the function or the exponent over here. So we differentiated sine x, and you got what? Cos x times the length of the constant over here. So you have length 4 times the whole function, the original function given, which is 4 exponent sine x. Okay, so our last step, we see that the 2 over here can cancel the 2 over there. Okay, so you have 1 plus x plus square root of x squared minus 1 over ln 10 times x plus square root of x squared minus 1 plus this one cos x ln 4 exponent sine x. Okay, so this ends question B. So we move to C, question C, or question 9C. Okay, just try to write it quickly. So question 9C, we have h of x equal to e exponent sine x plus 2x exponent 4. You have this h of x equal to e exponent sine x plus 2x exponent 4. You are asked to find the derivative. And this function here is an exponential function, okay? And the rule for differentiating an exponential function is that when you have, let's say y equal to e exponent g of x, the derivative of this one, which is y prime, will be equal to what? G prime of x times e exponent g of x. So this is the rule for differentiating an exponential function. Okay, so our target here is to find g of x and then differentiate it. So by comparison, we see that our g of x over here will be what? Sine x plus 2 exponent, sine x plus 2 x exponent 4. So we write, let g of x equal to what? Sine of x plus 2 x exponent 4. Alright, so g prime of x will be equal to the derivative of sine x, which is cos x, plus the derivative of 2x exponent 4 will give us what? 8x exponent 3. Alright, so we have our 8 prime of x, so we equal to what? D dx of e exponent sine x plus 2x exponent 4. And this one will give us what? D dx of sine x plus 2x exponent 4 times e exponent sine x plus 2x exponent 4. Alright, well, what's the derivative of this one? That's our g prime of x. Okay, so in place of d dx of this one, we write cos x plus 8x exponent 3. So we have cos x plus 8x exponent 3, all multiplying e exponent sine x plus 2x exponent 4. So this is our derivative for h. So this is our solution to question C. Okay, let's take it again. We have h of x equal to e exponent sine x plus 2x exponent 4. You are asked to find the derivative or differentiate this function. So first of all, you have to apply the rule for differentiating an exponential function. This is an exponential function, e exponent. This one is an exponential function. And the rule says that if you have an exponential function, e exponent, a function, just find the derivative of the function, the exponent, and multiply it by the original function, as simple as ABC. So you find our g of x to be sine x plus 2x exponent 4, which is the exponent over here. Then we differentiate it. Differentiating this one, you get cos x plus 8x exponent 3. Okay, you know how to do that. And we write that our h prime of s is equal to what? The derivative of, actually we differentiated both sides. So h prime of s equal to the derivative of the right hand side. So here we apply the rule over here. We find the derivative of the exponent, which is d dx of sine x plus 2x exponent 4. Okay, times the original function given, which is e exponent sine x plus 2x exponent 4. Alright, so the derivative of sine x plus 2x exponent 4 is what? Cos x plus 8. You multiply the exponent by the constant here and you get 8. You write your x, you subtract 1 from the exponent, you get 3 times the original function given. Okay, so this is the solution for the C, and we have the last one, D. So just take 2 seconds to copy this one, then we go to question D. Alright, so we clean it and move on. Question 9D, you have g of x or q of x equal to sine of cos of tan x you have this function and you also find the derivative. Q of x is equal to sine of cos of tan x. This one is a function inside a function and another function inside that function. So you have to do multiple differentiation over there. So our Q prime of x is equal to d dx of sine of cos of tan x. Okay. So firstly, we differentiate the first function, we get cos, then we differentiate the second one and the third one. So the first one, we differentiate sine, so we treat the whole of this one as an angle. Okay, so you have cos of cos tan x times the derivative of the function inside the sine. So the derivative of the function inside the sine is cos. Okay, so we have minus sine of what? Tan x. Then again times the derivative of the function inside the cos. So the derivative of the tan x here will give us what? Sec squared x. And when you find the derivative of the function inside the tan is x, so the derivative of x here is 1. So actually, there's no need for us to write the 1. So you have this 1 as your derivative, okay? So looking at it, you can bring the negative out. So you have minus cos of cos tan x then sine of tan x, then sec squared x. So this is our solution, or g prime or q prime of x. Q prime of x equal to that. So let me take it again. So we have q of x equal to sine into bracket cos of tan x, and you are asked to find the derivative, or you are asked to find q prime of x. So you differentiate both sides, you get q prime of x equal to d dx of the right hand side. Okay, so here in differentiating this one, we have what? 1, 2, 3 different functions over there. So you treat the whole of this one, cos of tan x is inside the sine. Okay, so the sine is pregnant with cos tan x. So you differentiate the sine first, you treat the whole of this one as one angle. So when you differentiate sine, you get what? Cos. So it becomes cos of cos tan x. So you put the whole of this one inside the cos. That one will give you the derivative of the sine. Then you come again, you differentiate what is inside the bracket. So you differentiate the cos here, you get what? Minus sine. You treat this one as an angle inside the cos. So it will be minus sine tan x for the second one. Then you come to the third one, you differentiate tan x, then you get the derivative of tan x is what? Sec square x. So we just try to bring the negative out and you get negative of everything here. So we are done with question 9, and we shall continue another day with question 10 and 11. Thanks for watching. Make sure you go through and understand it better. Okay.